before I hand out the review for 3 and 4, I'm just going to go through a few things because it's been a while since we've covered a couple of these things. Chapter 3 talks a lot about parallel and perpendicular lines. If I gave you a segment like, let's say, FG, and I ask you to name a segment that is parallel to FG, what would be a segment parallel to FG?
BC.
Okay, BC. We could also do AD. We could also do HE. Okay, they're on the same plane as one another, but they're on the opposite side of the plane. So like these are on both sides of the right side of the plane. Okay, and what it might do sometimes, and we saw this a lot of times too, is it might say name a segment or line parallel to FG but goes through A. And so then it's looking for one specific line or segment. Okay, so we got to be really careful about that. Let's put your phone away, Darston, please. Then we could go perpendicular. Okay, so if I said name a segment perpendicular to FG that goes through H. Perpendicular to FG and goes through H. What's a segment that touches H and is perpendicular to FG? HG. Okay. Here's H, so that means it has to connect with FG, and they're going to meet at G. So HG would be that. Okay. Skew, you're going to see that word today. We don't really talk about skew a whole lot. Okay. Skew means not parallel. And then it has to be not intersecting. So if I once again did FG, I could say DC, or I could say AB. Those would be skew to FG because they're going different directions, okay? And they will never cross, they will never touch. So that would be what we're looking for when we look for skew, okay? You're going to see that on your review today. So kind of reviewing some of those things. We've seen a lot of these a lot throughout the semester, okay? These are really important pieces. Some we've seen more than others. Alternate interior is probably the one we've seen the most. And when you look at these two lines, we don't know if they're parallel. In fact, they don't look like they are, right? But what we got to remember here is that the lines don't have to be parallel. If they're parallel, then we know more information. But if we're looking for alternate interior would be two that look like that. Okay, they're between the two lines, and they're on opposite sides of that transversal. Corresponding angles would be an angle here and an angle here. Okay. Alternate exterior would be an angle here and an angle here. They would be outside and then would be opposite sides, sorry. They'd be opposite sides of each other. And then consecutive interior would be on the inside, okay? And what we talked about, if parallel, then these angles are congruent, okay? For all three of these pairs, if the lines are parallel, which they're not here, but if they were parallel, those three pairs would all be congruent. What about consecutive interior angles? What do consecutive interior angles make if these were parallel? If I tell you that these two lines are parallel, what would we know about those two angles? Hannah?
180.
180, okay. They would be supplementary. Okay, so that's the one that's different if we have parallel lines. Hey, on this picture here, we're using that relationship if they're parallel, or in order to make them parallel, then, for instance, on this one, what would be the relationship between those two expressions? What do we know about x plus 5 and 2x plus 15? First of all, what kind of pair would they be? What would we call these two? Alternate exterior, okay. And what do we know about alternate exterior? If these are parallel, they have to be congruent. So I would set this equal to this, solve for x. And then sometimes it may ask us what the angle would need to be. Sometimes it may just ask us what x has to be. In this case here, these two don't have a relationship, okay? But what I could do is, for instance, say this and this are congruent because they are corresponding angles. And so I could put 4x plus 15 right here. And then these two together make a straight line, so they would have to make 180. So they may not have a relationship as they sit, okay? But I could put it somewhere else, so then I could make it have a relationship. And the only two relationships that we have in a picture like this is they're either equal or they're 180. That's it. That's the only two relationships that we talked about when we have parallel lines. So don't try to make more out of it than what there is, okay? If they are equal, we set them equal. If they're 180, we add them up and set it equal to 180. That's the only two relationships that we talk about. You're going to see a couple of problems like this today. Basically, it's the same problem except for one word. This one says parallel. This one says perpendicular. Okay? So first thing I'm going to do is I'm going to look at this equation, y equals negative 2x plus 5. And we have to determine what the slope is of that first equation. What would be the slope of y equals negative 2x plus 5? This is one of those formulas that's going to be on your formula sheet. Y equals mx plus b. Negative 2 over 1. Okay, this is my slope, this is my y-intercept. And one thing I will remind you of is we are not going to use that 5 at all on this problem. All we care about is the slope, okay? And so it's negative 2 over 1. And if it's parallel, that means my slope stays negative 2 over 1. And we're going to go through the point 3, negative 7. And then we plug it into y equals mx plus b. This is my x, this is my y. The only thing that I don't know in this equation is my b value. So I'm going to plug these three things in to my equation, and then I'm going to solve for b, okay? And then I'll have my equation. Always write your equation like this when you're done. The only thing different about the second problem is my slope is still negative 2. We don't care about that slope, or that number, which is my y-intercept. But if I wanted to identify the perpendicular slope, we have to do two things to my slope. What two things do we do to make it perpendicular? Reciprocal, okay? Flip it over and? Change the sign, opposite, okay? We flip the switch. And so this would become 1 over 2. Okay, and once again, this would be my x, this would be my y. We plug it into y equals mx plus b and solve for b. Okay. That second part, plugging it into the equation, are you guys good with that? Do you want to see an example of that? You guys okay with how to do that? Negative 3 equals 1/2 times 6 plus b, and then solve for b, okay? So just finish it out and get b by itself. And then put in your m and your b. Okay, transformations. Remember, the test is going to be multiple choice. And so you probably aren't going to have to draw a translation or a transformation, but you're going to have to identify what's going on, okay? And so there will be some transformation questions on there, but we got to remember the difference between all of them, okay? A rotation just means we're taking it and rotating it. We didn't see very many rotations, though, okay? So rotation is probably not going to be one that we're going to really focus on. A dilation means that you are making it smaller or bigger, okay? The triangle is going to get much larger, it's going to get much smaller. Okay? And we call that either a reduction or an enlargement. If K is less than 1, it's a reduction. If K is bigger than 1, it's an enlargement. Okay? If I said K is 2, then we're going to double the size, or 3 would be tripling the size. If it's a translation, we're moving it left, right, up, and down. Okay? We're moving it some direction. In some cases, maybe multiple directions. Maybe we're going to move it 5 to the right and 3 up. A reflection means we're going to flip it over a line. Okay, so I sometimes call this a slide. I sometimes call this a flip because we're going to flip the whole figure over the line. Okay, those would just be some words that we used. Reflection would be the more geometric word that you're going to see. So this one here is a translation. What does x minus 7 tell me I'm going to do? What am I going to do to the x value? What direction does x move? Unlike the x-axis. Moves left to right, right? So if I go x minus 7, what direction am I going to move my x values? Left 7, okay? So this one's going to go left 7. And then my y value is going plus 2, so it's going to go up 2. Okay, so a plus and a minus tells me moving left, right, up, and down. If I had 3 times x and 3 times y, then this is going to be an enlargement by 3 because we're tripling the size of our original figure, both x's and y's. It's going to be 3 times bigger. Okay, if my k is less than 1, then this is going to be a reduction by a fourth, or 0.25. 0.25 and 1/4 are the same thing. The reason I use a fourth here is because it's going to be 4 times smaller than the original instead of 4 times bigger. Okay, if I see x equals 1 and y-axis, where would the line x equals 1 be? What would it look like? If I graph the line x equals 1, what happens? Or what would that line look like? Straight up and down. Okay, it's going to cross the x-axis at 1. And that would be the line that I flip over. I'm going to take all my points and flip over that line. Okay, and then the y-axis could be another one. And the y-axis would also be vertical. Okay, I could also flip over the x-axis, or if I said y equals something would be a horizontal line. So those are the different types of reflections that we did. Okay, this one here is just trying to get from the blue shape to the green shape. The first thing I would do on something like this one especially, what do I notice about the blue figure compared to the green figure? It's smaller, or it's quite a bit bigger, right? So I got to make it smaller. And so for instance, QP is going to match with which side on the blue figure? KJ, right? Because it's going to be this side and this side. Okay, so what I'm going to need to do first of all is I need to make it smaller. This is a length of 2. This is a length of 4. So this is 2 times bigger than this. So I got to take all of these ordered pairs and divide it by 2. So that would be the first thing. Okay, and then once I get it to there, then I look and see what I still have left and see what I need to do. This one's also going to need flipped at some point because I need this to get flipped over here, and I need this piece to match up with that piece. So we're gonna have to dilate it, we're gonna have to reflect it, and then I may still have to move it left, right, up, or down once I do that. There was a part to your formula sheet, and I'm going to tell you about this, but the formula sheet